Good evening, everyone. Can you hear me? Am I audible? Please say good evening, everyone. Hello. Good evening, everyone. Good evening, everyone. Can you hear me? Am I audible? Can you hear me? Am I audible? Good evening, everyone. Can you hear me? Am I audible? Hello. Please say good evening, everyone. Okay, let me introduce myself first. I'm Lijo Joseph. I'm a trainer in physics. So, hope you had a very good chemistry examination. How was it for you? Could you please comment in the section? Many questions that were discussed in our live sessions came as such in examinations. So, as we promised in the beginning, this is going to be of real help to you. Okay, am I clearly audible? Yeah, okay, thank you very much, thank you very much. So for the late joinees, let me introduce one more time. I'm Lijo Joseph, I'm teaching physics, and we got one more teacher here, Rafi sir, he'll join after me. So today we will be having question discussions from first two chapters, Electrostatics and Current Electricity. Alright. Over the next couple of days, we will have revisions of all chapters. We'll be doing MCQs and most expected questions from all chapters. So, hope you will be with us throughout these sessions. And this is definitely going to help you to score A1 in finals. So, shall we start now? Everyone say yes, please. Okay, so I'm starting off with questions from electric charges and fields. Now here we have the first question. An electron and a proton are in a uniform electric field. The ratio of their accelerations is. Actually, it's a very simple question, but this is very important at the same time. We have seen electrostatic force being written as F is equal to Q times E. Electrostatic force experienced by a charged particle is given by F is equal to Q times E. Q is the charge and E is the strength of electric field. Okay, and we also have learned that electrostatic force is ma, mass times acceleration. So what is the situation here? We got an electron and a proton entering an electric field. Okay, so imagine you have an electric field which is created by a positive plate and a negative plate, and a proton or an electron or a charged particle for that matter enters this electric field. So what will happen? This particle experiences a force given by Q times C. Why? Because imagine this is an electron. Electron is negative. Electron will be attracted towards positive plate. Or if it is positive, that will be attracted towards negative plate. Anyway, the moment the charged particle enters the field, it experiences a force. And force is given by Q times E. And I can equate these two, which will give me ma is equal to QE, and acceleration is written as QE divided by m. Now this is known as electrostatic acceleration. Whenever a charged particle enters an electric field, it experiences an acceleration given by QE divided by m. And look at this. Here we have electron and a proton. So I can write acceleration of electron as charge of electron is E. I don't put minus sign because I am looking at the magnitude only. Then electric field is E. Mass of electron I can put me. Now let us call this equation number 1. And how about acceleration of proton? Acceleration of proton is given by, again, charge of proton, that is also E. Electric field is E, capital letter E, because both the electron and the proton enter the same electric field. Then mass of proton is written as EMP, equation number 2. Now you are asked to find the ratio of accelerations. How do we find the ratio of accelerations? Let us just put it straight away. Acceleration of electron by acceleration of proton is equal to, tell me what you got, EE divided by ME, mass of electron, divided by EE divided by mass of proton. If you cut the common terms out, you are getting what? This is going to the numerator. So that will give me, I am writing it here, acceleration of electron by acceleration of proton is equal to, this is going to numerator. So that gives you mass of proton divided by mass of electron. And you know the mass of proton is very, very large in comparison with mass of electron. Mass of proton is what? Mass of proton, you know, mass of proton is very, very, very large in comparison with mass of electron. So as you can see, the numerator is greater than denominator. When the numerator is greater than denominator, the ratio will be always greater than 1. So here the answer is option D, greater than 1. Understood this, all of you? Could you please say that in the comment box? Hello? Right. But there is an allied question here. I'll tell you, in case they ask you to find which one has greater force, this is how you're going to do it. Force is given by, electrostatic force is given by Q times C, and electrostatic force on electron is E times E. Electrostatic force on proton is, that is also E times C. Because the magnitude of charge is the same for electron and proton. They are entering the same electric field, so capital E is also the same for both. So what do you understand? Electrostatic force is the same in the case of electron and proton. This is a previous board examination question. So if you compare these two, electron and proton experience the same force, but they have different accelerations. Why do they have different accelerations? Because they have different masses. Obviously, electron is lighter in comparison with proton, so electron will have more acceleration. That is why we got the ratio as greater than 1. Hope it's clear. We'll move to the second question now. Now, this is another important question which has come many times in board examinations. A charge Q is placed at the center of a line joining two equal charges, capital Q. Okay, right. So we got two charges here at the end of a line. This is plus Q, this is plus Q. And a charge is placed at the center. So right in the middle, you are placing another charge called a small letter q. Okay. So basically we have a system of two charges. Both the charges are equal in size and they are of same sign. Both are positive. And you're going to place another charge in the middle. Look at that point, in the middle, at the center, so that the system is in equilibrium. See this? The system of the charges will be in equilibrium. So they are talking about something called equilibrium. What is meant by equilibrium? What is meant by equilibrium? For equilibrium to happen, the net force on the system must be equal to 0. Okay? So we have a system of charges. The net force on the system must be equal to 0. Before I do that, I'll mark this distance as r by 2 and this distance also as r by 2. Why? Because I have placed the charge in the middle and the total distance is small letter r. Okay? So this distance will be half, this distance will be half. Then what? They say that the system is in equilibrium. Equilibrium means net force is equal to 0. If the net force is equal to 0, each of the charges will be in equilibrium. If the system is to be in equilibrium, what is the condition? Each of the charges must be independently in equilibrium. So, I could say that this charge is in equilibrium, this charge is in equilibrium, even the other one is in equilibrium. So, let us go to any n charge and taking this charge, and I am going to make the net force on it 0. Why am I doing it? Because in the question they say the system is in equilibrium. System is in equilibrium means each of the charges must be independently in equilibrium. Okay, what is the condition for equilibrium? The net force on any charge must be equal to 0. Net force on any charge must be equal to 0. So let us write both the forces now. Look at this. What is the force on this charge given by this charge? I can write it as K into, what is the equation for force between two charges? Coulomb's law tells you that it is K Q1 Q2 upon R square. K Q1 Q2 upon R square. So K into first charges small letter q, second charges capital letter Q divided by the distance between them is R by 2 the whole square. Okay, this is what? Force given by the central charge on the end charge. Now there is one more force which is given by this charge. What is the force given by this charge at the end charge? I can take that force as K capital letter Q into capital letter Q divided by the distance between them is, the total distance is R square. And I need this to be equal to what? This to be equal to 0. So this is what I have done. I have made the net force on the end charge equal to 0. Now tell me what that will give me. Look at this. I will take this to the right hand side. What am I getting now? K into small letter q into capital letter Q divided by, what is this? R square upon 4 is equal to, let us get this to the right hand side. What do we get? Minus K capital Q divided by R square. Now let us get the identical terms cut. What do we get now? Look at this. K is getting cut on either side. Capital Q gets gone. R square is gone. So on the left side, you are left with what? Look at this. This 4 will go to numerator. When you take the reciprocal, you are getting 4 small q is equal to, 4 small q is equal to minus capital letter Q. They are asking you to get the value of small q. What is small letter q? Small letter q is now, small letter q is equal to, this will go to the right side. That makes it minus q upon 4. That means the charge to be placed in the middle is 1/4 of the end charge with negative sign. For example, if you are putting plus 40 here, in the middle, you need to put minus 10 in order to get equilibrium. Understood this? Anybody, all of you? Minus q by 4. Anyone has questions? This is again one of the most important questions in this topic. Okay, all right. Hope it's clear, everyone. There is a time lag. It is not real time. That is why I'm facing a delay. Right. If you have any difficulty in comprehending, please feel free to tell me. Right. Okay. Right. Okay, so let us move to the next question. Okay. Right. Now, this is based on electrostatic induction, the concept of electrostatic induction. I'll tell you, 3 concentric metallic spherical shells of radii R, 2R, 3R are given charges Q1, Q2, Q3. Okay, so we got 3 metallic spherical shells. They are concentric. Concentric means what? They are all having the same center, right? So look at this. I got a sphere here. I got a second sphere here. I got a third sphere here, right? Look at this. I'm not sure if it is a good figure or not, right? Anyway, I got 3 spheres here. They are all concentric. What are the charges on them? They say the radii are r, 2r, 3r. So the innermost one is having a radius capital letter R. Second one has a radius capital letter 2r, 2 into capital letter R. Third one has a radius 3 times R. Okay, they are given charges Q1, Q2, Q3 respectively. Okay, so you're giving charges to this. This is Q1 and this is having a charge Q2 and this is having a charge Q3. Now why do I put the charges on the surface? Because charges always reside on the outer surface of a sphere, right? So these spheres are given charges. The innermost sphere has a charge of Q1, second sphere has a charge of Q2, third one has a charge of Q3. Now I'll tell you the concept of electrostatic induction. Imagine you are bringing a charged body close to a conductor, okay, close to a conductor. So what will happen then? You know, electrons will be pulled towards this side, the closer side. So if there are 4 positive charges here, there will be equal number of negative charges on the nearer side. Why? Why negative? Because electrons are pulled to this side. So electrons get clustered on the nearer side. Electron has negative charge. So electron, 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 electron. Now on the other side, the farther side, there will be 4 positive charges. Why positive? Because the first side is getting negative, in other words, the second surface is losing electrons. Correct? If this surface is losing electrons, losing electron is equal to gaining positive. Losing electron is losing negative. Losing negative is gaining positive. So that side will be positive. So that is the point. This is called electrostatic induction. So when you bring a conductor or when you bring a charged body near a conductor, the near end will have opposite charge and the far end will have same kind of charge. So let us apply it here. I'm using another, right, I'm using this, right. See this now, what happens when you have Q1 here, the inner surface of next sphere will have minus Q1, right? The nearest surface has what? If I bring in, if the first body has a charge of Q, the near surface has minus Q, far surface has plus Q. So in this case, this sphere has Q1, that will induce minus Q1 on the inner surface. Automatically, the outer surface will have how much? Plus Q1. So what is the total charge on it? Outer surface has now what charge? Q1 plus Q2. And that will induce what? That will induce minus Q1 minus Q2 on the inner surface of the third sphere. So what will be the next charge then? Plus Q1 plus Q2. Now see the distributions. The innermost sphere has a charge of Q1. Next sphere has a charge of Q1 plus Q2. Next sphere has a charge of Q1 plus Q2 plus Q3. Understood until here, everyone? Everyone, please. Can you hear me? Do you need a repetition? Tell me. Right. Okay. So see this. You know, we have a conductor, we have a body, we have a charged body, we have a charged body close to it. You are bringing a conductor. So then what happens? Electrons will be pulled to this side. So this side will be all negative. Why? Electrons are pulled to this side. So this side is full of electrons now. So how many electrons? Same as, the number is same as the charges on the first body. Right. So if the first body has a plus Q, the first surface will have minus Q and the last surface will have plus Q. And think about it. The black ones are what? The charges given already. Now this is Q1 on the innermost sphere. Then what? That will induce opposite charge on the nearer surface and same charge on the farther surface. Think of it that way. This is Q, that will induce minus Q on the next surface plus Q on the next surface. So look at this. This is Q1 and nearer one is minus Q1. The farther one will be what? Plus of it, plus Q1. So altogether there was already Q2. Now the outer surface has Q1 added. What is the total now? Q1 plus Q2. And that will bring minus Q1 minus Q2 on the next surface. If it is minus Q1 minus Q2, opposite of it, plus Q1 plus Q2 on the next surface. So what are the charges on the outer surfaces now? The innermost sphere has Q1, next sphere has Q1 plus Q2, third sphere has Q1 plus Q2 plus Q3. Understood now? Feel free to tell me. I'm ready to repeat, no problem. Okay. Everyone, understood? Shall we continue now? What if the radius ratios are different? No, it doesn't matter actually. It doesn't matter. All right. Okay. As long as it is a metal, near side will have negative charge, far side will have equal amount of positive charge. Okay. Now let us get back to the question. What have they given? It is found that surface charge densities on the outer surfaces are equal. See this? Surface charge densities on the outer surfaces. Surface charge densities on the outer surfaces. See this? They are not talking about inner surfaces anymore. So I can wipe them off. Right. This minus Q1 inside, this can be wiped out. So what do they say? Surface charge densities on the outer surfaces. Okay, so before I do that, tell me, what is meant by surface charge density? What is surface charge density? Surface charge density is sigma is equal to total charge by total area. Surface charge density is total charge divided by total area. So they say what? The surface charge densities are equal. What does it mean? Sigma 1 is equal to sigma 2 is equal to sigma 3. Sigma 1 is equal to sigma 2 is equal to sigma 3. Read it again. It is found that surface charge densities on the outer surfaces of the shells are equal. Outer surfaces. Look at this charge, outer surface. Look at this charge, outer surface. Look at this charge, this is also outer surface. So they say that they are equal. So I'm going to equate them. Tell me, what is sigma 1? I can say Q1 by 4 pi r square. Why 4 pi r square? Surface area of the sphere is 4 pi capital letter R square. Right, 4 pi r square. Now, how about the second sphere? Its charge is Q1 plus Q2. Q1 plus Q2 divided by 4 pi into, what is the radius of the guy? 2r, 2r the whole square. Now how about the third one? Q1 plus Q2 plus Q3 divided by 4 pi into 3r the whole square. Right. So let us see that again. What have they given in the question? They say that the surface charge densities are equal. Surface charge densities are equal, which means sigma 1 that belongs to the first sphere is equal to sigma 2 is equal to sigma 3. Sigma, I told you, charge per area. So for the first sphere, charge is Q1, area is 4 pi capital R square. Second one, charge is Q1 plus Q2, and area is 4 pi into 2R the whole square. Third one, Q1 plus Q2 plus Q3 divided by 4 pi into 3R the whole square. So let us obviously cut the common terms, or I'll take the first two terms, I'll form an equation, then I'll solve it. So let us see this. I'm taking the first two terms here. Q1 by 4 pi R square is equal to, this is Q1 plus Q2 by 4 pi into, what is 2R the whole square? That's going to be 4R square now. Now let us get the common terms cut. Tell me what you're going to get. 4 pi cut, R square cut. Eventually you are getting what? Look at that. 4. There is a 4 here. No, there is a 4. That's taken to the left side. So that makes it 4Q1 is equal to Q1 plus Q2. Now get this Q1 to left hand side. What do we get? That's going to give you, for Q1 comes to the left side, 4Q1 minus Q1 is equal to Q2. So what is Q2 now? 3Q1 is equal to Q2. Got this until here? Everyone? Any questions? Oh, come on. Tell me, everyone. Am I clearly audible? Tell me, guys, please. Everyone. Right. So let us have the last part here. Right. Okay. Right. Yeah, 30-second delay for message. Yeah, that happens, right? Right. Anyway, so we are actually halfway through with the question. Now the second part is what? We have equated the first two terms. Then you can do the same thing with first and third, or second and third. So hope you have finished until here. Now I'll just wipe this part off. Just give me a second. Is it okay? Right. So hope it's clear now. I got this number Q2 is equal to 3Q1. Keep that in mind. Right. So the last part, I'm going to take these two guys together. Right. What do I get now? Q1 by 4 pi R square is equal to, tell me what's on the right hand side? Q1 plus Q2 plus Q3 divided by 4 pi into, what is 3R the whole square? 9R square. Now again, let's get the common terms cut. Right, 4 pi gone. Right, R square gets gone. What do we get now? Let's get 9 to the left hand side. This 9. That number to the left hand side. What will we have? This 9 goes to the left side. 9Q1 is equal to Q1 plus Q2 plus Q3. From the previous equation, if you compare, you see that Q1 plus Q2 is what? That is 4Q1, right? If I remember correctly. Can someone help me with it? Is it correct? Q1 plus Q2 is 4Q1, am I correct? Am I correct? Q1 plus Q2 is 4Q1, am I correct? Everyone? Right, thank you. Thanks, Abid. Thank you. One more guy, please, everyone. Please motivate me. Please. Right. So this is like, you can put Q1 plus Q2 as 4Q1 if I remember correctly. So get this to the left hand side. So what do we have now? This is like 9Q1. Unfortunately, I don't have space here. So 9Q1 is equal to, for this orange bracket, I'm going to put 4Q1 plus last one is Q3. So what is Q3 now? Get this to the left hand side. 9Q1 minus 4Q1, that's going to be 5Q1. Now that I got everything, I can find the ratio. They're asking you to find the ratio. Hope it's okay to wipe this off, right? Okay, so what is the ratio? I got Q1 as Q1 itself, and Q2 was found to be 3Q1. And what is Q3 now? Look at that, and tell me. Q3 is equal to 5Q1. So if you find the ratio, that's going to be what? Q1 is to Q2 is to Q3 is equal to Q1 is to 3Q1 is to 5Q1. So again, cut those common terms. You're going to get what? Finally, the answer is 1 is to 3 is to 5. That's a very, very, very important question. It is actually from the reader. The same concept is mentioned in the reader. All of you got this? Shall we move to the next one? Everyone. Yeah, right. Okay, right. It's obviously on the tougher side, but anyway, you have to practice these kind of questions. You can expect questions at this level. If you want to score 10% or even above 95, these kind of questions are also to be done. Okay, so these questions are carefully selected. All right. So make sure that you attend all the sessions. Mathematics, chemistry, biology, everything. Okay, right. So let us move to the next one now. That's again a reader question. You must have done this in school already. I'll tell you, that's an easy one. Two spherical conductors B and C having equal radii and carrying equal charges. See, these points are very important. Equal radii, or particularly equal radii. They are having equal radius. Okay, what if unequal radius? What if the radii are unequal? Such a question won't come in board examinations. It's a typical competitive examination stuff. Okay, so two spherical conductors B and C having equal radii and carrying equal charges. So I'm just drawing them. This is A, this is B. All right. So first one is A, second one is B. And what do they say? They carry equal charges. Let us call them Q. This is Q, this is Q. Okay. Now what? Repel each other with a force F. They repel each other with a force F. So let us write that force now. What is the force of repulsion? It is given by Coulomb's law, KQQ upon R square. KQQ upon R square. I repeat this. Two spherical conductors B and C. Oh, they have called them B and C. Let us correct it. This is B, this is C. All right. So let us take this as B and this as C. All right. Then what? They carry equal charges and they have a force of repulsion, and a third spherical conductor having same radius as that of B but uncharged is brought in contact with B. A third sphere, this is called a C, it is uncharged. Look at that, it is uncharged. What does it mean? Uncharged means you haven't given any charges to it. So its charge is 0. Okay. Is brought in contact with B. So you're bringing these in contact. All right. Then brought in contact with the C. That is second part. Oh, this was A. Right, sorry. And finally you are keeping these in contact. So let me see the sequence one more time. A third spherical shell having same radius but uncharged is brought in contact with the B first, then in contact with the C, finally removed away from both. The new force of repulsion between B and C. You have to find the force of repulsion between these two. Now let me ask you something. Let us see this part later. Okay, that part later. Let us focus on the first part. Imagine you have two buckets of water. Okay, and the levels are different. One bucket contains more water Now what happens if you connect the pipe buckets through a pipe? Water flows from higher level to lower level until both have a common level, right? So similar way, when you keep these in contact, what happens? Charge will flow from higher potential to lower potential until both have a common potential. Okay, so hear me again. Who is flowing here? Here water is flowing. Until what? Until water levels are same. Here what is flowing? Charge is flowing until both have a common potential. So basically what happens here is, initial force I wrote it somewhere, F is equal to K into Q divided by R square. Now what? These are kept in contact. Since they are of equal radius, look at that, I told you beforehand, you have only equal radius case. The charge will be equally shared. So what will be the charge now? This sphere has a charge of Q. This sphere has a charge of 0. So if it is equally shared, what will each have? Q plus 0 upon 2. One more time. These two spheres are kept in contact. So charge flows from one sphere to the other until the charges are equally shared. Okay. So Q plus 0 by 2. What is it going to be? Q by 2. That means this guy is going to get a new charge of Q by 2. Even this guy is having what? Q by 2. Okay. That part is clear, right? Everyone, can I have a response here, please? Everyone. Oh no, tell me, what is this? Understood until here? Alright, so the charges here are what now? The new charge here is Q by 2. The new charge here is Q by 2. Now what? They are talking about keeping these guys in contact. Tell me what? There also charge will be shared. How? What are the charges? This sphere has a charge of Q. This sphere has a charge of Q by 2 by 2. Why? The new charge here is Q by 2. The charge here is Q. What is the average of them? That will be Q plus Q by 2 by 2. What is it? Q plus Q by 2. 3Q upon 2 by 2. That's going to give you 3Q upon 4. So I got the new charge on this. 3Q by 4. Even on this, 3Q by 4. And what exactly is the question? You got to find the new force between the original spheres. New force. Now this is removed. Its role is finished. Now you got to find the force between these two. Tell me what? Now the new force is K into, what is the new charge of this? What is the new charge of this? Q by 2 into, what is the new charge of this? 3Q by 4 divided by R square. Distance is the same. So what are the extra numbers here? Look at these numbers circled. 3, 4, 2. What is it now? Altogether, we have 3 divided by 2 into 4 is 8. What else do we have here? K, then Q by R square. What is it? Look at that. What is it? What is this circle? Can you tell me? That is our old force, right? So finally we get what? The new force is equal to 3 by 8 times old force. It's a very important question. It has come many times on papers. Make sure that you learn it. It is so important. It is based on sharing of charges. Remember, we will have only case of equal radii. Equal radii means both are having same radius. Alright. Then what? Charge will be equally shared. So first case, you are keeping these in contact. So there will be sharing of charges between them. So Q plus 0 by 2, Q by 2. And after that, you are keeping these two in contact. So Q by 2 plus Q by 2, that is 3Q by 4. Okay, so now the new charge is Q by 2, new charge is 3Q by 4. You are asked to find the force between them. How do you find it? Force is given by K Q1 Q2 by R square. K Q1 is Q by 2, Q2 is 3Q by 4 divided by R square. So if you remove those constant numbers apart, what are you getting? 3 by 8 times KQQ by R square. What is KQQ by R square? That's our old force. That makes it 3 by 8 times F. Hope you got this. Shall we move to the next question? Everyone? Everyone, please. The faster you respond, the more we can do. Right. So, see, I just want to confirm if you are hearing me properly. That's it. Okay. All right, Abid, Nathan, rest of the guys, tell me please. Okay, shall we move to the next question now? All right, moving to the next one. This is again another important one. It has again featured many times on the papers. This is called Millikan's oil drop experiment. Okay, anyway, just see this. A charged water drop whose radius is 0.1 micrometer is in equilibrium in an electric field. So, a charged oil drop is in an equilibrium in an electric field. Okay, if charge on it is equal to, charge on it is equal to what? Charge on it is equal to charge of an electron. So that is the key point given here. Charge on it is equal to charge of an electron. Charge of electron is what? You know this. 1.6 into 10 to the power minus 19. Okay, 1.6 into 10 to the power minus 19 coulombs. All right. So that is given there. And then intensity of electric field is the question. Okay. So I'll tell you the situation here. Now imagine we have an oil drop. This is an oil drop. All right. What if I keep an oil drop in space? That will fall down, right? Why? If I open the window and jump out, I'll fall down. Why? Why? Because gravity is pulling me, right? Gravity is pulling me down. Am I correct? Right. Same way, the same force will pull this drop down. So what if I don't want the drop to fall down? I just want the drop to stay afloat. Okay, I want to keep it floating. What am I supposed to do? There is a technique. I can give positive charges to it. Positive charge. Oh, they say it is electron, charge of an electron. Okay, fine, no problem. Either way, it's fine. So I take the drop here. It has negative charge because it is electron. Now it is trying to fall down. It desperately wants to fall down because of gravity. Because of gravity, mg. Right? Gravity is mg. Just like you and me. I am being pulled by gravity. So are you. Right? So this gravity is to be cancelled, nullified somehow. So if you want to keep the drop right in front of your eyes, you have to give some other force to balance this. How can you give it? How can you give it? This force is downward, so I need the other force to be in the upward direction. I can think of it this way. Look at this. I keep a negative plate at the bottom. I keep a positive plate at the top. Now this setup is known as an electric field, right? Now if I do this, tell me, negative repels negative up, positive attracts negative up, correct? So there will be a force in the upward direction which can be called Q times C, electrostatic force. So it is this way, you are taking the oil drop, The oil drop doesn't want to fall. Actually, oil drop wants to fall down. You don't want the oil drop to fall down. Correct. And you're keeping the oil drop here. Then it is being pulled by gravity and somebody is pulling it up. So that force is electrostatic force here. So what is the condition now? If it wants to stay afloat, these forces must balance. What do we have? mg is equal to qe. The downward force must be balanced by upward force. mg is equal to q times e. And let us see this. This question can lead to many different questions. I'll come back to that. But anyway, just know this. Mass by volume is density. You learn this. Cross multiply. Mass is equal to volume into density. Volume into density. What is volume of a sphere? Volume of a sphere? 4 by 3 pi r cube rho. Because sphere, every drop is spherical. I have never seen a cubical drop. Have you? No. All droplets are spherical. So volume has to be 4 by 3 pi r cube. So I am putting it straight away to this. 4 by 3 pi r cube rho. Where? In place of mass. Mass is 4 by 3 pi r cube rho into g is equal to q times e. Okay. Now let us put the values. 4 by 3 pi r cube. Radius is given. I believe radius is given. Yeah, radius is 0.1 micrometer. Radius is 0.1 micrometer. 0.1 micrometer. 0.1 micro means 10 raised to minus 6. Micro means 10 raised to minus 6. If you take it along with this guy, that's going to make it 10 raised to minus 7. Right. So I'm putting it here. 10 raised to minus 7 the whole cube. They say water droplet in the question, I believe. Right? Yeah, water drop. Water drop. Water drop means density of water is 1000 into acceleration due to gravity is 10. Is equal to, what is the charge on the drop? Charge on the drop is given, charge of an electron. What is it? 1.6 into 10 to the power minus 19 into electric field is the unknown here. You got to find it. Now let us cut the common terms. Look at this. Since it is MCQ, you can obviously cut 3 with pi. They are very close. Pi value is 3.14, but it is very close to 3. You can get them cut. No problem. So what do we have now? 4 into 10 power minus 7 cube. 10 power minus 21. 1, 2, 3, 4 zeros. 10 power 4. Is equal to 1.6 into 10 power minus 19 into E. What I want is what? Capital letter E, right? So I'll get capital letter E is equal to, I'll get it as 4 into 10 power minus 21 plus with 10 power minus 10 power 4 is 10 power minus 17 divided by, this guy goes to the left side, 1.6 into 10 power minus 19. So finally you get what? This 10 power minus 19, 10 power minus 17 cut, that will be 10 power minus 2. When it goes to numerator, it is 10 power 2. So what do we get now? That is E is equal to 4 into 10 power 2. That's going to be 400 divided by 1.6. 400 by 1.6 is somewhere around 250. 250. There is only one option which is so close. So is there any problem in approximating pi? No, nothing. Because all these options are far off from each other. Got it? So the final answer is option C. All of you got this? Can I have a response, please? All of you? Everyone, please. Yeah, okay, right. So moving to the next one now. Now this is again another important question. Right. All of you, right. Okay, so moving to the next one now. We have a charged ball hanging from silk thread S, which makes an angle theta with a large conducting sheet as shown. The surface charge density is proportional to. Okay, so you got to know two things before I start. First one, you know, for a sheet, thin sheet, electric field is given by sigma upon 2 epsilon 0. Electric field is given by sigma upon 2 epsilon 0. And here in this case, I am keeping the sheet this way. You are not seeing the front side. The sheet is, you are seeing the edge of the sheet here, edge of the sheet. Okay, it is kept this way, right. And there is a thread on which a bob is suspended. It is like a simple pendulum. And second thing is, you have learned about tension in class 11. Tension is a force acting on a stretched wire. Acting on a stretched wire. For example, if you have a loose wire like this, there is no tension. But if you stretch the wire, there will be a tension on the wire. How do you mark tension? How do you mark tension? If this is the body, you know, tension can be marked as going outwards from the body. Outwards from the body. All right, along the string. Okay, so this is a stretching force and this is how you mark it. So you just have to know two things before we do the question. This is the question here, the context of the question. We have a positive sheet. Right next to it, a bob is suspended. Bob is suspended. All right, and it is making an angle theta. And you are supposed to find surface charge densities relation to theta. Surface charge densities proportionality with theta. So what are the prerequisites here? Number one, you need to know the electric field due to the thin sheet. Electric field due to the thin sheet is given by sigma by 2 epsilon 0. What is sigma? Surface charge density. What is epsilon 0? Permittivity of free space. Then second thing, if you want to mark tension on a free body diagram, that is how it is called. Mark it as going outwards from the body along the string. So let us come back to this question. One thing is certain, this charge must be positive. Tell me why? Can someone tell me why? Because this is repulsion, right? It is repelled. It is repelled, right? Am I correct? Oh, tell me, please, come on, come on, come on. I don't have too much of time left. Tell me guys, please. Right, this positive is repelling positive to the right with a force called QE. Electrostatic force. Electrostatic force is QE. Then what? Then what? Yes, electrostatic force QE. Then what? Tension. I'm going to mark tension. Look at tension. From the body outwards along the string. From the body outwards along the string. From the body outwards along the string. That is how I mark the tension. Now I can split this into two components. Why? Every vector can be split up into two components, right? Every vector at an angle can be resolved into two components. What are the components? Cos component and sine component. Cos component and sine component. If this angle is theta, this angle is also theta. Tell me why? Because these two lines are parallel and this one cuts both. So these angles are called alternate angles. Alternate angles are equal, aren't they? Yes. So this force will be what? The component close to theta is t cos theta and the component away from theta is t sin theta. There is one more force missing. Can you tell me please? Which is the only force that's left? The same force that I have on my body. On your body. Gravity, gravity, right? Everywhere gravity plays. So gravity is acting downwards, mg. Done, finished. Now I've just represented all the forces on the body. See that again? One force is mg downward. Another force is electrostatic force to the right. Another force is tension, which may be split up into t cos theta and t sin theta. Okay? Now what? They say that it is in equilibrium. Do they say that? Right. Yeah. It hangs means it is in equilibrium. It is kept like that. Okay. Equilibrium means the forces must balance. So what is the condition for balance? The force to the left, T sine theta, must balance the force to the right, QE. That is equation number 1. Force to the left is T sine theta. That must cancel force to the right. The force upward, that is T cos theta, should balance the force downward. Okay, equation number 2. Nothing. For equilibrium, forces in all directions must cancel out. Okay, force in x direction, T sine theta gets cancelled by QE. T cos theta gets cancelled by mg. Right. So you can divide equation number 1 by equation number 2 now. What am I getting now? T and T are cut. Left side is sine theta by cos theta is tan theta. Tan theta is equal to QE upon mg. QE upon mg. I'm not done yet. What are they asking here? The surface charge density is proportional to. So you need to bring in what? Surface charge density into this. Where are you going to bring it? Q by mg. Do you see this orange circle? Do you see this orange circle? What is E? Electric field given by the sheet. That is given sigma by 2 epsilon 0. Now look at this. It's finished. What do you think about this? What do you think about this? Q is a constant. 2 is a constant. Epsilon 0 is a constant. M is a constant. Even G is a constant. All constants can be removed if you put proportionality. Right. So you could say tan theta is directly proportional to everything other than sigma can be removed. Sigma is proportional to tan theta. Answer is option B. All of you understood this? I'll do one more question. Then Rafi sir will continue with the rest of the session. One more question I'll do. Okay, all of you, could you please say yes or no? Understood this, everyone? Right. Hey, what is this? Tell me, guys. Just say hi. Right, please. Right. Thanks for that. Right. Thank you very much. Right. So, moving to the next one, I'll do maybe like 1 or 2 questions. This one is a very simple question. Okay. Now, see the question here. A particle of mass m and charge q is placed at rest in a uniform electric field. A particle is placed at rest in a uniform electric field. Then what? Then it is released. Kinetic energy attained by the particle after moving a distance y. Okay, after moving a distance y. Imagine an apple is falling from a tree. Okay. When the apple was on the tree, it had what kind of energy? Potential energy, right? Potential energy, right? Imagine an apple is on the tree and it had potential energy. And when it fell down, its potential energy got converted to kinetic energy. Am I correct? Am I correct? Same way, look at this. What do they ask here? A particle of mass m and charge q is placed at rest in uniform electric field and released. Kinetic energy. I'm going to use work energy theorem to solve this. Work energy theorem. Right. I'll tell you. Imagine this is the condition. This is the condition. Okay, right. Maybe like we have a field. We have a field like this. Into this, a particle is being shot. So, work energy theorem you learn in class 11 tells you what? From the name itself it is clear. Work energy theorem. Work energy theorem. Work done is equal to change in energy or simply energy. Work done is converted to energy. I'll tell you an example. Imagine you are standing in the middle of the road and all of a sudden a car comes and hits you. You will fly off, right? Where do you get the kinetic energy from? Oh no, tell me. You know, you are just flying off because the truck hits you or car hits you. and you got the kinetic energy from the work done by the truck. Or imagine in cricket, a batsman plays a ball, the ball goes for a sixer. Where does the ball get the kinetic energy from? It is actually work done by the bat or batsman, right? Same way, here the charged particle enters the electric field. It gets a kinetic energy, right? Who does the work? The field does the work, or rather the potential does the work. Okay, so I can write they are asking for kinetic energy. So how do you get kinetic energy? They are asking you to get kinetic energy. It is the work done. Work done you learned in class 11, force into displacement. You've been seeing since class 8. Work done is equal to force into displacement. What is force here? We are talking about electrostatics, right? So the force must be electrostatic force, right? Electrostatic force is QE, right? And what is the displacement? They say after traveling a distance y. So QE into y. So kinetic energy is QE into y. The kinetic energy obtained by the particle is QE into y. So the option C is the correct one. So it's very simple, but it is based on work energy theorem. So it's very, very, very important. They are asking you to find the kinetic energy upon entering a potential. Imagine you are jumping into a well. Then you will gain kinetic energy, right? What is kinetic energy? Work done by gravity. Work done by gravity, right? Same way, here the kinetic energy obtained by the particle is nothing but the work done by the potential or work done by the field. So kinetic energy is the question. Work done is force into displacement. Force is QE, displacement is Y. They have given that in the question. QE into Y is the answer. Understood this, all of you? One last question. I'll hand over this to Rafi sir. He will start the next part of the session in maybe like 2-3 minutes. Understood this? Can I have a response, please, everyone? Okay, this is another important question from the reader. Hope you can see this. It's very, very important. Figure shows the tracks of 3 particles in a uniform electrostatic field. Uniform electrostatic field. Which particle has highest specific charge? Have you heard this word before? Specific charge is another name for charge to mass ratio. Charge to mass ratio. For any particle, charge divided by mass is called specific charge, Q by M. For electron, it is E by M electron. For proton, it is E by mass of proton. So specific charge means they are asking you to get charge to mass ratio. Now let me redraw the figure here. It is not clearly visible. We got an electric field. It's a reader question. Electric field, and we got plus and minus here, and 3 particles are going. Particle number 1 this way, particle number 2 this way, particle number 3 this way. And this is 1, this is 2, this is 3. And you know, in reader, there is another part to this question which is very easy to do. You have to identify the nature of the particles. It's easy because the one going towards positive will be negative. Why? Positive attracts negative, right? So particle 1 will be negative, particle 2 will be negative, particle 3 will be positive. Okay, now I'll tell you this. They are asking you to find which one has greatest charge to mass ratio. All right, so I am doing this. I am writing this equation which you learned in class 11. Displacement time formula. This is part of the equations of motion. S is equal to ut plus half at square. Ut plus half at square. Look at this. Here, the particle was shot in the x direction. X direction. Did you give any velocity in y direction? The particle was fired in x direction, horizontal direction only. Any of these particles were not given velocity in y direction. So let us write this equation in y direction. Why y direction? That makes it very simple for you because you are finding the y displacement. Look at that, y displacement. This is y displacement. This is x displacement. This is y displacement. Okay, so I'm not bothered about x displacement. I'm simply looking at y displacement here. Okay, so I'm applying the y direction. Displacement in y direction may be called y. What is initial velocity? What is initial velocity? Can someone tell me, please? I said beforehand, initial velocity is given only in the x direction, horizontal direction. In y direction, initial velocity was what? 0. You never threw it down, right? Did you? No. Right? You projected the body in the horizontal direction and you are simply looking at y displacement. So what is y displacement? This guy is going to be 0 now. 0 plus, because initial velocity is 0, half into, this is acceleration, electrostatic acceleration. We learned it in the first question, QE by m. If you remember, electrostatic acceleration is QE by m. Because electrostatic force is QE and F is equal to ma, you can equate them. M is equal to QE, A is equal to QE by m into T square. Now see this, I'm done. Right, y is equal to what? Half into QE by m into T square. Now look at this, they are asking about specific charge, Q by m. So I am bothered about Q by m only. Look at this Q by m, look at this Q by m. Other than that, everything is constant. Look at that, electric field. All the particles enter same electric field. All the particles, particle 1, particle 2, particle 3, they enter the same electric field, right? Same electric field. So E is the same for all. We are taking this over a given time. So time is same for all. Half is same for all. So cut them out. Right. What am I left with? I can put proportionality. Q by M is proportional to Y. Okay, Q by M is proportional to Y. Look at this, because half is a constant. E is same for all. T is the same. So as you can see, only thing that matters is Q by M. So you can say Q by M. If you remove all the constants out, you can say Q by M is directly proportional to Y. So that is our key point now. That's it. Now who has greatest Q by M? The greater the value of Y, the greater the value of Q by M. Greater the value of Y, greater the value of Q by M. Okay. So they are asking for the one with the greatest specific charge, highest specific charge. Highest specific charge is the one with largest value of Y. Look at this guy's Y. It is very small now, right? Look at the next one's Y. It is little more than that. Look at the third one's Y. That is the largest of all. So look at third particle. Third particle has what? The largest Y value. Third particle has largest Y value. Largest Y value means it has the largest Q by M. Largest Q by M. Greater the value of Y, greater the value of Q by M. They are directly proportional. Greater the value of Y, greater the value of Q by M. So largest Y is for third particle. So largest Q by M is for third particle. Third particle. So answer is option C. Understood this, all of you? That's all from me for the time being. Now you will have the second part of the session to be handled by Rafi sir. Okay. Now he'll be taking questions from current, electricity and capacitors. All right. So stay in the meeting room. We'll come back in a minute. Right. Thanks. Bye.
Yes. Hi. Good evening, all. Good morning for the other students. Good evening. Good afternoon for other students. Welcome all to the wonderful sessions. Hopefully, you enjoyed the session with my colleague Lijo sir. Now we are dealing with the next part of physics. Okay. Yes. Hopefully, I am visible. My audio is fully audible to you. Just give a proper comment on the chat box. Let's start our discussion then. Can I start now? Are you guys ready? Yes. Use the chat box. Use the chat box, all of you. Let me realize your presence. All right. So can I start? Yes. So let me start the session. I am going to start with the potential questions. This is really a 5-star questions to you, like a very outstanding questions, mind developing questions, eye breaking questions. Let's break the eye. So dear children, you want to study this one with take a book and pen and do with this with me. Okay. One more thing I am suggesting you, keep a coffee or something in your study table. Let's enjoy the sessions. I hope you guys are tired today because you you attended today the chemistry test. Soon after you are trained these revision classes, etc. Now you are again at night you are working. So don't worry, children. This is the last lap of revisions we are doing here. So don't worry. Let's enjoy the sessions. So we can start these enjoying sessions. All right. So let's begin with the first question. Here you are seeing one of the questions from capacitance part. Let's look this. Okay, you can read this one. You can read this one. Can you try this? Yeah. What is this question? Find out the equivalent capacitance between A and B. Take the area of the plate is A. Sir, where is the plate here? That's your confusion, right? Don't worry. I will show. Listen. So dear all, this question, you have to approach this way. So you are not identifying where is your plate, right? So this question, you just imagine this kind of question when you can imagine like a battery is attached. An imaginary cell is connected between the 2 points A and B. Think about that way. Okay, if this kind of questions where cell is not present in the capacity circuit, then they asking what is the total capacitance between A and B. What you guys can do, the first step, imagine a imaginary cell which you attached between those 2 points. All right, understood? Then I will show you. It's like I told you, it's like a mind developing question, 5-star category questions only we are exploring in the sessions. All right, come on. So this is a positive, right? It's a positive. So where the positive goes to the point A. So whatever the plate which is connected to the point A, all receive what? Tell me. This all receive positive charges. See this? The plate A. Why this plate become positive? Wait, okay. Yeah. Why this plate A become positive? Because positive terminal of the battery attached here. So look at this. Through the positive again flows through where? This point A and reaches somewhere here. Okay. So this plate become what? Positive. Understood that point? Now tell me where the negative goes. Negative goes to B. Okay. So like bad boy goes to, yeah, similarly negative goes to the B and this region become what? Negative. All right. This region become what? Negative. Now focus on this. So you still think about where is your plate, right? Don't worry. Yeah, you can visualize. So it's a side view basically. Okay, I think Lijo sir also explained that one of the concept to you. So did you remember that? See, what this line is not actually line. It's not actually line. It's like a plane. See, if a plane kept like this, when you view from the front side, what you are seeing? A straight line, right? Oh, you guys are engineering graphics students and all, then you know this, right? If a line like this, it's not a line basically. It's like a front view, right? It's a front view of a plate. And this another plate, is another plate, is another plate, like that. Understood now? So visualize. So, okay, now see this. Let me number this one, okay? This number is 1. And this plate, this plate is common for, how many capacitors are you seeing here? 3 capacitors are there. Can you say that one? This is one capacitor A. This is one capacitor B. This is one capacitor C, right? Positive and negative plates separated by some distance. All right. How many such arrangement you are seeing here? 3. A, B, C. Did you get that? Yes. So this is a point 1. And let me number this, okay? This is a plate common for the A capacitor as well as the B capacitor. So let me call that plate as some 2 numbers. 2 and 3. Okay, let's break. So then you can see here this plate also you can call it as what? 4 and 5. Understood? And this plate is, you know, it's not surrounded by another capacitor, so we can call that is one name, that is 6. All right. Now see this one. Let me go to redraw this. Okay, focus on this. So the point A, let me mark here. The point A, let me mark here. And the point A connected to the plate 1. Let me mark this plate 1. Okay, now we are converting into our conventional capacitor diagram. It's a plate 1. Then what is another one? Plate 2. Look at this, plate 2. Plate 2 here. Where the plate 2 attached? Sir, the plate 2 attached where? Tell me please. It's point B. Understood? Yes. Now see where the 3. Sir, 3 and 2 are common, right? 3 and 2 are common. So let me take, you know, one more arrangement for you. So 3 and 2 are common. I am splitting this plate into 2. Okay, so 2 and 3 are common, correct, right? Yes or no? Yes. Now see the fourth one. Where the 4? Sir, the 4, 5, 1 are same, right? 1, 4, 5 are same. Understood? Yeah. So come on. The 3. What's the partner of 3? Come on, it is 4, right? And where it is the 4 joined? 4 also joined to the A. Are you getting this diagram? New diagram. I told you, know, it's like a mind-breaking question. All right. Yes. Now see, 4 I drawn. Where is 5? 5 and 4 are same, sir. 5 and 4 are same. So 5 also begins from where? 4. Yes or no? Yes, sir. Fine. Then see, the next 5 partner is what? 6. Where 6 attached? 6 attached to the point B. 6 attached to the point B. Samajh gaye ho? Yes. Then focus on this. All right. Now see how these all capacitors are now. Sir, it is parallel. It's parallel. It's a parallel arrangement. Understood? It's a parallel arrangement. So look at this now. Now how to solve? Are you getting this? Now how to solve? You understood this all are parallel arrangement because all positive plates are joined commonly or negative plates are joined commonly. Common terminal connection is kya bolega? It is called it as parallel connection. Understood? It's a parallel connection. Now see, let me call this one is A. That is A, right? What do we call this one? It's called B. This is called what? C, right? 3 capacitors. Can you say what is the value of capacitance A part? This small cute portion capacitance is how much? Come on. The area of plate is A and the medium between it is air, epsilon 0. What is the distance between the plate? Did you read that? Distance between the near plate is given, it is D. So A epsilon 0 by D. Understood, right? So what is then CB? What's then CB? Is there a difference? No, sir. It's also area of the plate is A, distance is D, epsilon 0 by D again. What is CB? So what is CC? Third capacitor. Same only, right? So can I write then this is all equal? CB, CC, all are equal? All are identical capacitor? Yes or no? Yes, sir. This all are now identical capacitors. Tell me, identical capacitors are joined in parallel. What's the total capacitance value? Okay, identical capacitance joined in parallel. What's total capacitance value? N times C. What is N? Total number of capacitor. C means what? Value of each. How many number of capacitors are there? Tell me. 3 numbers are. What's the value of each capacitor? A epsilon 0 by D. So 3 A times epsilon 0 by D. Okay. So this is just a welcome question to you. Hopefully you understood this one. It's the B is the right answer. A. It is really a welcome question to you. Understood this one? Yes. A 3 times A epsilon 0 by D. I told you, this is not a normal level discussions. It's beyond. To make you perfect, bringing you to the top level. That's what the Excel physics team really doing here. All right. So welcome all to the wonderful session through this particular questions. Let's enjoy the second question then. All right. Yeah. Can we? I hope you guys are getting this. Let's look at the next question now. Focus on the next question. Hopefully you all got our welcome laddu, right? Yes. Now focus on this. Another sweet question to you. Listen to this. A parallel plate capacitor. You can read. You guys can read this. Please read 1 minute. Silently read it. Okay? I will explain. Silently read this question. A parallel plate capacitor. Hopefully you are writing with me, no? Yes. Then do. A parallel. Don't waste your time. Okay? Don't waste your time. This is not entertainment session. We are conveying a quality content to you. So please be right. Then do the solutions with me. All right. A parallel plate capacitor with air between the plates. When it is air, what's the capacitance value? 8 pf. What is pf? Picofarad. How much is picofarad? Tell me. 10 raised to minus 12. Hey, you want to talk inside your room, okay? You want to talk inside the room. What is 8 picofarad? I am listening your voice, what you are saying. 8 picofarad means what? 8 into 10 raised to minus 12 farad. Alright, so what is the capacitance? What's the capacitance when it is air? What's the capacitance when it's air? 8 picofarad. Should I want to convert into picofarad to farad? If it is a board examination, some questions come, pico how to convert? By multiplying 10 raised to minus 12. But here guys, don't convert because options are, look. Options are in picofarad. You don't want to convert, okay? Keep as it is for this time being. But board, you want to present in SI unit. So farad, 10 raised to minus 12 farad. All right. Okay, now what will be the capacitance? What is easy question, okay? I hope anyone waiting for to the next question, right? Sorry guys, I'm just talking to the entire students. So just wait for that students, like outstanding students. Just wait for a minute. I will explain this one, then I'll come back to the next excited questions. Oh, look at this. What will be the capacitance if the distance between the plate is reduced to half? What's the distance between the plate is called, say all, distance between the plate is called a D. What happened to D here? D become D by 2, right? D become D by 2, and the space between filled with the substance of dielectric constant, how much? 6 are dielectric constant, what we representation? 6, right? So, tell me what's the new capacitance when a dielectric slab is inserted fully between the plates of capacitor? What is the capacitance formula? Speak! I hope you guys are saying that formula, K into A epsilon 0 by D, right? Yes, great then. K into A epsilon 0 by D. Afrin, you are saying now? K into A epsilon 0 by D. Tell me, what is actually distance between the plate here? So, distance between the plate is D by 2. Alright, now let's substitute this one. Come on, this 2 goes up. What's the K value? K value is 6, right? This 2 goes up. K value 6. So, 6 times A epsilon 0 by D. What's A epsilon 0 by D? Could you tell that? What's A epsilon 0 by D? Sir, A epsilon 0 by D is 8. Right, because capacitance in air is what we called A epsilon 0 by D. How much it is? 8 picofarad. So what can I call A epsilon 0 by D? Which is 8. So therefore this will be 8. So 2 into 6 into 8. How much it will be? 2 into 6 is 12. 12 into 8 is, I think, option will be 96, right? Yeah, option will be 96. 96 picofarad. You got no? This is a board expectable question. The previous question will be in board, if they are, that's for making like 100% score. I told the 5% of the question were board always keeping like the CBSE board always keeping like a little bit difficult. But CBSE don't need like, the student who to reach like 100 full mark in physics. That's really a glamour question. That's why they keep like 5% of the question were really hard. Such category of question which I done, the first one. Hopefully that's fine to you, right? Yes. So, but you guys can reach, okay? You guys can reach the 100% level. Make a sleepless night and enjoy the days because there is no more physics sometimes come in front of you. So, it's the last moment. So, work hard. We are giving energy to you. All right. So, let's go to the next question then. Let's move to the, are you okay with this? Can I go to the next question? Hopefully getting, let's explore the next question. Come on, whatever the question you are seeing in capacitance, like a circuit questions and all, similar question you can also expect for in resistance area also. Just replacing the capacitance portion by a resistor, then that is a question from connectivity. Is both chapters are connected. Okay, so while you are analyzing the circuit questions and all, you want to expect like replace the capacitance with the resistance, then think. Okay, then think. Such questions also you can expect in current electricity. All right. Yes, so this is like buy one get two. It's like a buy one get two. Whenever you learn capacitance part, then you are getting, so you are also getting what, some field to solve some good field to solve the current electricity questions also. All right, let's break this question. It is a special type question. It's a special type question. Look at this. First of all, let me tell you how many some students, 70% of students were in mathematics student, right? Did you see this question in mathematics? Did you see this question in mathematics? I hope our mathematics teachers, in Excel mathematics teachers, maybe discuss this to you. Like this quadratic questions, right? I think the 10th kids might solve this one, right? Do you remember? So root of 7 plus, it is still up to infinity. Hey, don't fall in sleep, okay? Don't fall in sleep. I will come back. So see, y is equal to, I'm not teaching the mathematics, but I am telling you this mathematics question is related to that physics questions. Look at this. Y is equal to root 7 plus, root 7 plus, root 7 plus, root 7 plus, till up to where? Infinity. How to solve this question? Oh, sir, it's really difficult, sir. No. We have simple trick for this. A special method is there for this kind of summation of this kind of infinite series. Let me tell you that. I hope someone you know this. Okay, how to solve this one? We will call, the other than all repeating unit, we'll call it as what? It is call it as y. We'll call this part is what? Tell me. This call it as what? Y. Sir, you called already. This is y. Ender thing is y. Yes, that's also y. Why so? Because, sir, this ender thing you added with very chota things. Nah, come on. You added this ender. This still up to where? Is it only here? No, it is still up to infinity. So such a big series, you are adding this a chota number. Then how it that result will change? Result will not change. So I can call this part is also y. Samajh gayo? Understood that? You understood? You're getting me. Yes, so you can call this is what? Y, right? So what this become? Tell me. Y is equal to root 7 plus y. Root 7 plus y. Then how to solve this one? Yeah, you have to square on both sides. When you square on both sides, what you will get? Y square is equal to 7 plus y. Then how to solve this one? Yeah, make a quadratic equations. Y square minus 7, y square, what you will get? Come on, tell me. Y square minus y minus 7 equal to 0. You got quadratic equation, hence you can use like a different method, you know that, minus b plus or minus root b square minus 4ac by 2a. Such operation if you do, you will get what? The y value. Yes or no? So this is the idea. Why I taught this moment this thing. Look at this, children. It is because in an infinite series comes, how to solve this one? Other than the repeating unit, you can call what? This is a special approach. Other than repeating unit, what you can call? It is again the total result. Alright. Why so? Because you are adding such a big value with a smaller value, it does not changes the answer. That's why. Hopefully that is okay to you. Let me move to my question, the physics question here. It's also such a series, right? It is not ending here. Come on. It's not ending here. It is still up to infinity. That goes to infinity. So how to do this one? Tell me, what is repeating here? Tell me, what is repeating here? Yes, sir. 8, 6. 1 unit. 1 more 8, 6, 1 more 8, 6, 1 more 8, 6, 1 more 8, 6. So it's like, repeating, right? So what is repeating here? Could you tell that repeating one? Yes, sir. This is what repeating. So I can call this ender thing is what? It is, I can call like what? This ender resistance, let me call, sorry, it's not resistance. Sorry for that. So this ender capacitance, I can call what? C, sir. From here to infinity, what can I call? I can call that is C. Got it? Yes, sir. Then what's the total capacitance? Sir, total capacitance also you can call C. You're getting? Are you connecting this question to the previous mathematics question? What is the total I called? What's total I called? C. Sir, then this also I called what? C. Why so? Because this is still up to infinity. Itna bada number you are adding like a chota number. Does not changes the final answer. That's why. Understood? Yes. So this is the trick which you are doing. So with the help of this idea, can you convert this diagram? Yes, we can convert the diagram. Come on, let's convert this diagram. This is what the point P and this is what the point Q. Okay. Now see, this is what 8 microfarad, like a first cycle. The repeating, the repeating unit, one repeating unit you want to take. Like, the 1 root 7 we taken, right? Rest only we call it as Y. Similar way. Yeah. So come on, we take that. Then this one also we taken. This is keeps on repeating. Yes or no? Yes, sir. Then what we call whole other thing, whereby we call it as what? Tell me, this is called it as C, right? That's called as C. What's the total value? Total value also C. Now I think you guys can try this. Can you try? Yes. What's the total capacitance will you call? It is C. Tell me how to solve this one. Total capacitance also call it as C. So once again, I'm reminding you to, here, we set like an MCQ question, but this is not an exactly MCQ questions. This can be asked like a 2, 3, 5 mark questions. Such kind of quality MCQs are set here. All right? Yes. So come on. Sometimes it can be also asked like what? MCQ. Leave it about that. But you don't want to bother. You want to study for this all questions, catch it the all content. Come on. So what's the total? We call it as C. Now how to solve? Yeah, sir, these two are, tell me, this 6 and C are, how it is connected? So these are series connection, right? Series connection. How will you find the total in series connection? So when two capacitors are connected in series, tell me, when two capacitors connected in series, C1 into C2 divided by C1 plus C2, product of capacitance divided by sum of the capacitance. Okay, what's total capacity? This one, can you say very quickly? 6 into C divided by 6 plus C. Are you okay? What's total of this one? Tell me, 6C divided by 6 plus C. Product of capacitance, speak with me. Product of capacitance divided by sum of the capacitance. So 6C divided by 6 plus C. Are you getting? Yeah, don't sleep, okay? Don't fall in sleep. Drink a coffee and be energetic. Okay, this is just a motivation to, run like 3 more hours. You have to run this proper studying. Okay, proper study and cover up these portions, because this is the last days you are getting to for learning physics. Okay, yes. So see, 6C divided by 6 plus C is the total of this. Then tell me, let me convert for you. So see this one. Could you tell what is this point? P. This point is what we call the Q, and what we call this resistance 8. Not simplified area, 8. What's the total of this one? Come on, 6C plus 6C divided by, speak all, 6C divided by 6 plus C. Are you okay? Now you know what's the total of this one. Sir, it's a parallel connection. Just add them. Okay. So total capacitance we can call what? So total capacitance what we call? C, right? Hey, that's the trick we used here. So total capacitance C, then 8 plus 6C divided by 6 plus C. Now you can solve the C, right? Will you solve that? Let me leave from there. No, sir, you can do, right? Okay, I will do. Yes. So just cross multiply this one. 8 into 6 plus C plus 6C divided by 6 plus C. Will you do? Wait, the 6 plus C you can bring to here. What you will get then? 6 plus C, where I will write. Okay. I can write here, no? Yes, sir. So 6 plus C you can multiply with C. How much you will get? 6C plus C square. Are you okay? Yes. After you are getting 6E plus C square. That's fine. Then what's other side? What's other side? Come on, multiply. 8 you should take into the bracket. 8 into 6. 8 into 6 will be 6 into 6. Solve that what? Yes, so that is 48 plus 8C plus 6C. You can simplify that portion. So I hope if you solve the quadratic equations and all, you will get C as 12 microfarad, I think. Can you check it, okay? Just to do the quadratic equation simplifications, you will get it. Let me leave from that questions. Hopefully that's mathematic part. Okay, in case if you are not getting, you can put the comment on the chat box. I will update you the solutions correctly. I think from my mind, I am thinking that the value of answer I am getting like a 12 microfarad. You can do that quadratic equation solutions. All right? Yes. Let me go to the next question, because within short time we have to finish this paper. So look at the next question, all of you. Look at the next question. A parallel plate. Read. First I am giving a time to you. Read please. Read please. A parallel plate capacitor, as a separation is D, capacitance is 20 microfarad. If a metallic foil of thickness, metal, okay, metal, what is inserting? Metal. How much thickness of that metal? Say thickness of the metals are 2/7 of D. Introduced between the plates, then capacitance will become. Can you say the formula? Yes, sir. Yeah, let me say the formula to you. There is a plate of capacitor. If you learn this formula, you might have to solve. You can solve like in board question 2 mark. Okay, so remember this formula. So plate of a capacitor, in between the plate of capacitor, suppose you are inserting a metal. What you are inserting? Metal. What's thickness of the metal? T. And what's the total distance between the plates of capacitor? That is D. Then do you know what will be the capacitance formula? Capacitance formula. What is this one? Metal. Do you know what's the capacitance formula? This particular case, K into A epsilon 0 by D minus T. That's the formula. Okay, between the plates of capacitor, if you insert a metal, then what will be the new capacitance expression? Okay, K into A epsilon 0 by D minus T. Where T stands for what? T stands for what? Thickness of the metal. Understood, right? All right, sir. Now see. Okay, so let me substitute then formula. C dash is equal to sorry, it's not K, okay, A epsilon 0 by D minus T. Sorry for that. So A epsilon 0 by D minus T. Capacitance of metal is inserted. So that's for dielectric, right? I hope you are correcting me. Yes. So when a metal is inserting, what's the formula? A epsilon 0 by D minus T. All right. So A into, so focus on this, A into epsilon 0 divided by D minus T. What's the thickness here? Thickness. Tell me the thickness. 2 by 7 of D. Thickness is how much? 2 by 7 of D. If you simplify this, can you simplify this? Easy, no? This is easy question. Come on, let's simplify. Yes, this is how much you will get. You will get this is 5D by 7. Am I correct now? Can you check? 7D minus 2D, 5D, 5D by 7, right? 7 goes up, 7 by 5 will come. So we will get how much? 7 by 5 into A epsilon 0 by D. Okay, that's a new capacitance. Now what is this one? What is this? Is it unwanted data? No. That is actually when air is present, the capacitance is what we call the A epsilon 0 by D. That value is given 25 microfarad. Okay, so A epsilon 0 by D place, you can substitute what? The 25. Substitute that all of you. 7 by 5 into 25. So you can simplify, no? So this become 5. 5 into 7. Option is there, no? Yes, option is there. 35 microfarad. 35 microfarad. Clear? Understood? Easy question only. Remember that metal inserting formula. What's the formula? A epsilon 0 by D minus T. Learn with me. A epsilon 0 by D minus T. When dielectric is inserted, what's the formula? K epsilon 0 by K into A epsilon 0 by or K into C in air or K into A epsilon 0 by D. Okay, hopefully you know that. We can discuss that kind of questions also. It's an easy questions, expectable board pattern. Fine, right? Yes. Let me go to the next questions. Sometimes, if I might a calculation or error happen, you just use the chat box and convey to me. Okay. So because I am talking, I am doing, etc. You guys are only writing, no? So you might feel, no, you are like you're only doing, you're fully concentrating. I am concentrating here a lot of things. So what will happen? Sometimes might a error happen. So it is don't compare the talent. Okay, don't compare the talent. Leave it. I'm a human being. All right. Yes. So let me move to the next question. Come on, we can do the next question. So read this one. Oh, this is a little difficult. But don't worry, this is the highest level of questions. If you learn this question, then you can solve all chota boys questions. Then you can do all chota boys questions. This is the maximum level of questions from this particular part. Okay? Yes, so we can do this one. Don't worry, okay? If you are not studying this one, listen with me and you can learn this particular questions. So when you got the idea of this particular question, then you can do the similar trend questions very quickly. All right, so let's focus on that particular question. A parallel plate. Can you read this? Read for 1 minute. Make it fast. First, understand what is the data given. Are you getting the complete point? In order to understand the physics solution correctly, you want to spend proper time for what? The questions. Okay? Yeah. So can you read this question? Yes, all. Come on. A parallel plate capacitor of plate area is what? A. Plate area is A. Plate separation is what? D. Plate separation is D. Capacitance is C. Filled with 4 dielectric material. I think more than this question will not come for the board examinations. Okay, this is a maximum level of question you can expect. What are the dielectrics? Are K1, K2, K3, K4. K1, K2, K3, K4 as shown in the figure. If a single dielectric material to be used to have same capacitance C in this capacitor, then what will be the dielectric constant is given by? Sir, nothing understood. Yeah, what this question said? Don't worry. Relax. Cool down. We can break this question. Okay, I will help you. Come on. So see, first I will tell you an idea how these capacitors are here. So this were the plate actually. These are the 2 plate. Okay. See the answer they go. This is what 2 plates of capacitor. Okay, like this. So it is really bad for us now. Can we make it vertical? Yes, we can make it vertical. Okay. So I think it's more space is needed for this. Anyway, let me try here, dear all. So lot of space is required for doing these questions. Anyway, I will try. Okay, I will try. Just held this capacitor is vertical. Then it's very common pattern to you. Come on, let's redraw then. what I done? These are the plates of capacitor where the area marked. So what's the total distance? The total distance by total distance is called say all total distance is called D, right? Total distance is D. Can you redraw this? Come on. So the center line, there is a center line. I'm making this horizontal capacitor to the vertical direction. So this is center line. See, this is center line. All right. So here it is filled three things. This one portion is filled with the K1 dielectric. Another portion will be filled with what? K2 dielectric. Another portion is filled with what? K3 dielectric. Understood? No? Understood. Are you redrawing with me? Carefully focus. Okay. Yeah. This question you might feel like little bit difficult. Don't fall in sleep. Okay. Don't fall in sleep. Okay. So focus. So what this one? It is a K4. It's a K4 is here. K4 is there. So what is the area of the plate? What's the area of the plate of this portion? A by 3, sir. What's the area of this plate? Because total area is A. 1/3 only here, 1/3 only here, 1/3 only here. Come on. This become what? A by 3. What about this one? It's become A by 3. Right? What's the area of this portion? Sir, this total plate area is involved in the K4 part. So this total area will be A. Did you observe the all things? All right. They said in the question will be, you can read the questions later. One more, after getting the solutions. You want to repeatedly do these questions, okay? Yeah. So such a quality questions. So this is, they are given that this is equivalent to like a parallel plate, single parallel plate capacitor, okay? A single one. If you replace this kind of combination dielectric and all, if you replace it by a single dielectric, then the capacitance of this arrangement and this arrangement are equal. Then question is asking what's the value of that K? What's the relationship with that K and K1, K2, K3, K4? That's what the question is. What is given? There's a parallel plate capacitor. They arrange in this kind of fashions. So this ender, what's the capacitance of this combination give to us? The same thing is given by a single dielectric which is completely filled inside the parallel plate. Then obtain the value of the K. That's what the questions. I told you, this is like an MCQ questions, but it's not an MCQ standard question. It can be like higher order questions which you can expect like in section E category questions. Okay? Yes. All right. Yeah. Focus on this. How to solve this one. Let me tell you one more point, one more information, lot of information needed to this questions, okay? I will tell you the another information to you. So see all, suppose you want, let me build up some basics to do these questions. Okay, look at this. There's a parallel plate capacitor. So see this one. If you are filling a dielectric held, every questions in plates of capacitor comes, you just think like a plate is held vertical. Then you can use this trick, which I am saying. Okay, come on. If it is, filled like this, K1, K2, like, what this combination in my language, I am saying like this, above below combination. What I will say? Dielectric is filled what way? Above below combinations. Remember, last moment you are preparing, above below combination is you can consider like what? It's a parallel combination. Above below combination you can consider what? Parallel combinations. Like, that's just the basics to you, okay? Just a basic to you. If it is connected like this, Marabai, if it is connected like this way, K3 and K4, the dielectric, okay? Dielectric material is filled this manner. What is one? Sideways filling, left-right combination, left-right filling. This is, you can treat like what? Series connection. Okay? Left-right series. Above below will be what? Parallel connection. Remember that trick, okay? So in order to solve this question, what do you want to do? This trick you can only use when you held the plates of capacitor is like a vertical, like this way. Then see how the dielectrics are filled. If the dielectrics are filled like above below, then it is called what? Parallel connection. If it is sideways left-right connection, then it behaves like what? Tell me. It's a series connection. All right, now hopefully you got that concept. Now focus on this. Tell me this one then. Here multiple connections comes. This one, how it is filled? Did you check? Is it I kept this plates of capacitor vertical? Yes, sir. You kept it vertical. Okay? I'm making like a physics solution, you can do in multiple way. While a different teacher observing this video, they will think that, hey, Rafi sir, why you are doing this? Why are you doing this way? You might feel, sorry teacher, I am doing my own way. Okay, so kids, we have multiple steps are there. We can solve the physics. Mathematics also same way. You can use any mathematical convenient step. All right? Yes. So see, we held the plates of capacitor vertical, and how these dielectrics are arranged here, like above below combination. Above below combinations are, it is a parallel Sidewise connection will be series. Are you getting this? Yeah. So I'm teaching like a really basic student. I'm just focusing on, you know, this outstanding question itself, but I am focusing on the like the babies in physics also. Okay. So the outstanding students, you might feel, Professor, why you so lag? No. I'm just, if I talk only for you, then I will quickly come to the solutions. For this time being, I want to look my, you know, the chota kids also in physics. I want to pull them up. So that's the reason why I'm just, you know, entering to the deep level. All right. Yes, sir. How this K1, K2, K3 arranged above, below? So these connections are, tell me, these connections are what we called parallel connection. Then what about K4? So K4, it is series connection, right? Sidewise. Okay. These three are parallel, right? Above, below. And then the K4, it is, come on, K4, it is series connection. Got it? Are you with me? Yes, it's a series connection. So with the help of this one, can you redraw this? Yes, we can redraw this. Yeah, all right. So let me redraw that diagram to you, okay? So there is a K1, it's a K1 dielectric, and sir, it's a K2 dielectric. They are parallel, sir. They are parallel. K1, K2, K3 are parallel, sir. Then, you know, it is series with the K4 part, sir. It's series with the K4. Understood? It's series with the K4. I told you, know, lot of spaces needed for solving this. So you guys can, you know, rewatch this again. Okay? So we will save this one. Focus on this. So K1, K2, K3 are parallel. K4 it is series. Fine, right? Am I correct? Yes, sir. You can continue. Yes. Now tell me, could you tell what's the capacitance of this arrangement? What's the capacitance of this arrangement? May I call that is 1? Yes, sir, you can call 1. What is filled here? Dielectric. When dielectric is filled, what's the formula? Speak all. K1 into A epsilon 0 by D. But careful. What is the area of the plate? Tell me, what is the area of plate for Amara Chota K1? That is, sir, not enter the plate. It is A by 3 only. It is A by 3 only. Dhyan se dekho. So see here. What is this one? K1 into A by 3. A by 3 epsilon 0 by D. What is D here? Oh, that's also surprising. I told you, lot of things are accommodated here. Come on. So what this portion is, distance between this arrangement will be D by 2. D by 2. Sir, distance is D by 2. Lot of, it's a mind developing question. I told you, if you solve this question, then, it's really hot. I feel hot here because of this question. Such a question, such a glamour questions like me. Okay, leave it. So this is what C1, this is what C1. The 2 goes up and become what? 2 by 3 into K1 A epsilon 0 by D. Are you okay with that part of capacitance? Yes, sir. Now, can you say the C2? What's the value of C2? Could you tell similarly? C2 also same, right? Because the area, distance, all are same. So come on, C2 also same. But C2 has slight difference. Can you say what's that difference? Sir, dielectric is K2. Dielectric is what? K2. So therefore, rest of the everything will be, you can think it is same only where the K2 has a change. Okay, K2 has a change. C2 you got. What about C3? C3 also same, right? Because area of the plate is like A by 3, distance is D by 2. When you substitute that, you will get same thing only. You only want to show for the first question, for the first C1. Rest of them, you can mark like similarly. You can write the answers. Okay, you can write the answer. The solution is like a question is a little lengthy. Okay, so you have to focus well. Those students who want to, not getting the point, you can rewatch it. I thought that I discussed very basic level, this questions. Okay, this question is like a 7-star, not 5-star, beyond that, 7-star questions. But I'm making this symbol. I hope all my bacho watching from India, watching from all GCC country, this is getting. All right, so come on. What is K4 then? Can you say what is K4? K4? C4 will be C4. This portion, can you say K4 into, what is the area of that plate? Focus. You're not losing your mind, right? What's K4 plate area? That is A. K4 plate area, tell me. That is, sir, it is A. All right. Epsilon 0 by, what about the distance? Distance is half of the D only. So it's become D by 2. K4 has a slight difference, okay? You want to be careful. So you have to give full attention here. I think Nihal is making mistakes. Yes. So listen, that is what C4. All right. C1, C2, C3, C4. You got all 4. Okay. You got all 4. All individual capacitance you got. Now can you solve this? I hope you can solve. Yeah. This is, look at this. One more data which is given in the question. Did you notice that? This entire arrangement is equal to a single capacitor. A single capacitor which is filled with a dielectric K. Area of the plate is what? A. then what's the total capacitance of that arrangement? K into A epsilon 0 by D. So what's the idea? Let me tell you the trick. The students who can do this one. Yeah, come on. You have to find the total capacitance of this arrangement. This all are parallel. Then this is series. So you will get some value, and which you can equate with the total capacitance is how much? K epsilon 0 by D. By equating that, you can cancel A epsilon 0 by D. Then you will get what? The K. Can you try this? Let me leave from this question. Can you try this? Are you taking that challenge? No, officer, you can do. Right? That's what somebody is saying. Okay, I can hear. Yes. So let me solve to you. Don't worry. So, but you want to say the data to other page, okay? Yeah. So here we have a limited space only. Yes. So what is that? Okay, it is there in my mind. So hopefully you got the figure, you got the diagram. Tell me, these three are how they are connected, parallel, right? So what is the total capacitance in parallel connection? How will you find that CP? CP called what? CP let me call C1, C2, C3. That name is correct. C1, C2, C3 are parallel. So that total part of the capacitance, parallel connection, how will you find? Could you tell C1 plus C2 plus C3, right? Parallel connection. You just add them. So can you say what is C1 here? 2 by 3 K1. You want to add this, then C2 here, C3 here. While you're adding this, may I skip one step to you? Are you getting? Your mind is developed such a way. Yeah. While you're adding this one, what is common? If you need, I will write that step. I'm avoiding that. So 2 by 3 A epsilon 0 by D is present in all, right? Can we take its common? Yes, sir, you can take it common. While you take that common, tell me then, 2 by 3 into A epsilon 0 by D, you can take common. Then what is inside the bracket present? Then what is inside the bracket present? Here K1, here K2, here K3, right? Inside the bracket, speak all K1, K2, K3 were present. That's what, you know, the total capacitance of that parallel arrangement. Understood? It's not completed. Okay, fine. Professor, it is an MCQ. Yes, it's an MCQ. Yes. So it's MCQ which is asked in a competitive test. So, you know, all CBSE, like later they're converting into the JE level questions into like they put into this CBSE board examinations. Okay, this is like Bada Bhai. If you can solve this one, I'm definitely believe that all Chota Bhai questions you can easily do. So try to work on it. Put an effort over here. Yes. So you got that CP, right? You got that CP. And then tell me, this parallel unit and this one, how they arranged? Series. So series you had to do one step. So when series connection, how will you find the total capacitance? 1 by CS is equal to, speak with me, 1 by C1. So the reciprocal of total capacitance in series connection is equal to sum of the reciprocal of individual capacitance. That's the formula, right? Okay. So can I come to that point? Yes, because, yeah, come on. The total capacitance. What's the total capacitance? Could you tell that? Yes, sir. Total capacitance is, you called like a single combination, right? Yeah. What is that? 1 by K epsilon 0 by D, which is equal to 1 by C1. How much is C1? What's C1 unit here? A. What is C1 unit here? C1 I call, you know, like what I am saying now, please focus. This entire unit is, you know, one capacitance. And that is our called CP, right? Then this one is series. Are you confused? No, right? So that part will be this part. Tell me, you should write that 1 by that part of capacitance. You have to substitute A epsilon 0. Is it I missed any term? No, right? Can I continue? Am I correct? I hope I am correct. Let me continue this. Then look at the next series unit. This is a series unit. What's the value of it? 2K4 A epsilon 0 by D. So that is 1 by, don't forget, okay, 2K4 A epsilon 0 by D. Am I correct? Yes, sir. Then who is celebrating the birthday here? You can cancel them. Yes, sir. A epsilon 0 by D. A epsilon 0 by D. A epsilon 0 by D. Present in all term. Cancel. What is left then? Tell me. I hope we are reaching close to the answer now. Yeah, what is left here? 1 by K. 1 by K, which is equal to 3 goes up, right? So what you will get? Tell me then. 3 by 2 into K1 plus K2 plus K3 plus, tell me the last one, 1 by 2K4. Yes or no? Yes or no, my children? It is 1 by 2K4. what you can do? Multiply complete term by 2. So you will get 1. If you multiply every term by 2, 2 by k. When you multiply 2 here, these 2 get cancelled. You will get 3 by k1 plus k2 plus k3. And if you multiply 2 here, you will get what? 1 by k4. So that is the final answer. Don't worry, first you will feel it's difficult, but you should keep on practice. Then it is a great question to you. You can solve all the simple chota question under it. Expected, you got it, no? You can rewatch this. Every video will be present. You can rewatch it. This is the final answer. Okay, so we can check that that is there in the option. So that is there in the option C. Look at this. That is there in the option C. I know this question is a little heavy. The student who are like an average is definitely feel it is heavy. But don't worry, children. You have to understand each and minute step which I told. You can use that tip and you can solve the questions. Any doubt is there, you can contact me. You can contact us, the Excel science team or Excel physics team. We will help you. We'll help you provide the solutions. Okay. So this question, how to come to like a discrete level. Let me tell you that. So obtain the relationship between K and this all dielectric that they will convert. Or another possibility, prove that the dielectric constant will be this one that they may give. Okay, that they may give. Understood all? All points are clear to you? Can we break one? Can we do one more question then? We can do one more question. All right. Now this is like winding up question. Okay, winding up question. I given a green laddu at the beginning. Now I am just giving is another sweet laddu so that you are getting energy. So we can break this question. Next, a very beautiful question. I think you might feel like you can do this. Yeah, you can do this. But first attempt you might error. No. Listen. We can solve. Can you read? Read please. Yes, read please. The equivalent capacitance between A and B. The total equivalent capacitance between A and B. It's also a mind developing question. Okay, mind developing questions. Come on, let's do this one. We can solve this. Find the total capacitance between A and B. Come on, guys. How to solve this? I am waiting you. You're thinking, right? Okay, then I will break the question. Hey, can you look at this point, these places? Here it is the magic place. Okay, so look at this. Okay, look at this point. Look at this point, all of you. This capacitor, sir, this plate of capacitor is connected here. I told you, this kind of capacitor question, if you replace the capacitor, resistor question also can come. Okay, it's like buy one get two offer. If you replace this whole capacitor value by resistor like 4 ohm, 2 ohm, then it's a question from resistor part. Come on. So this point once again. Why this happen? All right, wait. So see here, this plate of capacitor is joined here. Yes or no? Where this plate is joined, sir, this plate is also joined from there. Where this plate is joined, sir, this plate is also joined from there. Common starting. One condition of parallel connection is valid there. Look at the next plate. Where this plate is connected, sir, this all plate is connected here. No, come on, look at this. Focus on this. This plate is also connected. In between, nothing is present. So did you get that? All points were commonly connected. Starting points, common starting, common ending. Parallel connection. Come on, bolo. Common starting, common ending. So it's what? Parallel connection. So do you get this? All three are parallel connections. So can you say what will be the total? I'm doing here. Okay, I'm doing here. You should solve detail in your book. So this all are parallel connection. Tell me, in parallel connection, what's the total capacitance formula? Add them. 5 plus 2. How much is 5 plus 5 plus 2? 12, right? Yeah, it is 12 microfarad. You guys confused? No, it's not it's not that much big numbers, easy numbers only. So 5 plus 2 will come. It is 12. Understood, right? Can you look one more part here? One more cute part is here. Let's focus. Yeah, let me use a different color for that. So if you see that one, then you guys are great, bacho. Come on. This 2 microfarad, where it is connected, sir, it is here. Where this 4 microfarad connected there. Where this other plate of capacity, 2 microfarad, is here. Where this 4 connected here. Oh, sir, these plates are also commonly connected. This other plates also commonly connected. Marabai, that's also acute parallel unit is present there. So what about the total of that? Can you say the total of this will be 2 and 4? The 2 and 4. Tell me 2 and 4 total. So parallel connection total capacity will you find sum, right? 2 plus 4. Tell me 2 plus 4 6. So that will be 6. So it's not pico, right? It's microfarad. All right. That's fine. That's great. Yes. Now can we redraw? Yes. So let me start from the point A. What's the first capacitor? Sir, first capacitor will be 6 microfarad. 6 microfarad. Can we convert this all 3 to all all 3 into 1? What's the value of that? 12. So let me mark that magical position here. Let me simplify that magical position here. Come on, bacho, how much it will be? Compress. 12. That's 12 microfarads. Become a single one. Similarly, can you do a small compression here also? These two you can convert into a single one. Come on, 2 and 4. What's total? That will be 6, sir. That will be 6. Understood? So that will be 6. And now it is a very, very familiar circuit to you, right? Yes, sir. 6. This all are how it is connected. Series. So how will you find the total capacitance in series? Yeah, reciprocal. So take this reciprocal 1 by 6 plus 1 by 12 plus 1 by 6. Can you solve that? If you solve this, I think if you solve this 1 by C, so 1 by 6, how much you'll get, or you can multiply. You can do all mathematical way in which you can, that's a mathematical step you can follow. Let me make a common denominator, so multiplying 2 here, multiplying 2 here, multiplying 2 here, multiplying 2 here. So all are common denominator, all are 12. Denominator is 12, then numerator how much? 2 plus 1 plus 2. How much it will be? 5, right? So 5 by 12. Okay, am I correct? 5 by 12. So 5 by 12. So C will be 12 by 5. Okay, this is 1 by C. Don't forget, many kids will be forgot to take the reciprocal. Ulta. So 12 by 5, 1 by 5 will be 0.2. So 12 by 5 will be 12 into 0.2, which comes to be 2.4. What's the unit we solved? Microfarad. Is there in the option? Yes, sir, it is there in the option D. Did you get this cute, wonderful questions? Yes. All right. So dear all, we will continue this kind of series in upcoming days also. You can share maximum to all of your friends which are going to, appearing the board examinations. Let's enjoy. Okay, and you have to share these things to your brother also. Such a beautiful physics classes. Me, Lijo sir, and other physics faculty are really live in Excel. Really give, we can learn this complete physics is like, in Excel Education Center. You can learn like very entertainment way. Physics is, many students were coming in front of me saying like, Professor, physics is so boring. No, physics is not a boring subject. That means when you come to like a quality teachers, I'm not quality teachers, but my friend Lijo sir is a quality persons, and other teachers also quality persons. So those teachers, will give you. I'm also try to be a quality. So we will give like a quality content to you guys, and you can make like a great concept in future. You have to share this informations. We are in Qatar. We are actually making a very beautiful physics sessions, chemistry sessions, and all biology sessions, all sessions for every kids like who are appearing like a 7 to 12 standard, NEET and JEE. Basically these questions, last question, that's the JEE questions. Those JEE questions. We are giving correct coaching to the all special like classes and all. So promote us. So thank you all. We can see tomorrow by another chapter. Beautiful discussion. You can enjoy. Thank you kids. Good night. All the best. Keeps on fire and steady. Thank you all. Bye. Salam.